Okay, I think we can go ahead and get started. Good afternoon, students and faculty. Thanks so much for your time and being a part of this delightful presentation today. So Mr. Burke Squires is a UD alumni, class of '94, graduated in biochemistry and computer science. And he has worked in many different sectors over the years. His CV is quite robust. He has worked both within Dallas and in other parts of the US, currently working in DC for the National Institute of Allergy and Infectious Diseases, which is a part of the NIH, National Institutes of Health. His talk today is titled Bridging Faith and Science in a Pandemic World. So I will hand over to our distinguished speaker today, Mr. Burke Squires.
Thank you, Dr. Toby. So I'm going to go ahead and let's see if we will go ahead and enable screen sharing, please. All right, let's try this one here. And then I will flip these. All right, so you should see, let's see here. Does that look about right? Yeah, okay. All right, can everybody hear me? Yeah, all right. Well, I want to thank Dr. Toby for the opportunity to talk to you all. I was to say at some point in here, I will probably make reference to a talk of an alumnus scientist that I heard when I was at UD many years ago, and how that was instrumental in, I would say, kind of beginning the infectious disease journey of mine, as I've come to understand in putting these slides together. And so UD is a unique, wonderful place in the sense that it is a world-class institution, right, of learning. And with its Catholic identity, it is something that is becoming more unique in the world. And with that being the case, in trying to come up or think about what to talk about today, the ultimate title that came to mind was Bridging of Science and Faith in a Pandemic World. And so what I hope you will see today is that this is, I would say, a lot more autobiographical than I necessarily wish to normally talk about on a normal basis. But I think it is just an example of how, if we cooperate, right, with God in our work and our education and in our lives, that wonderful things can happen. All right, let me move this little thing out of the way here. Okay. And so what we're going to do is we're going to talk about personally, right, how I bridge science and faith in faith, family. We're not going to talk about citizenship. We're going to talk about education, and then a number of different aspects of work. And if you'll notice with regards to, say, education, and then the different aspects of the different facets of work, each of those has the 3 dots, which usually, or in this case here, means that there's more material to come, okay? And then at the end, we'll save some time for a Q&A, and I would welcome any and all questions that you have. If you want to interrupt me in the middle, please don't hesitate to ask questions, and I will do the best I can to answer them. So the first thing I'm going to do is I'm going to start out rather odd. I'm going to define science for what I suspect is an audience full of science majors. So here, according to not the Oxford English Dictionary, which is what I've always known it as, it is now the Oxford Literate Languages, the definition, or at least the first definition of science, is the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. I don't think there is really anything there that is surprising to anybody here. Perhaps it's been either a long time since you actually looked at the definition of science, or it is something that perhaps you've never looked at. And so I was to say I think it's probably been a long time since I looked at it. But in the context of our talk today, and I would say one of the theme that's going to come back over and over again, whether or not I actually mention the word, is provenance, right? And the fact that there is something bigger in the world guiding our lives, and that bigger thing, right, which I would call God, has created this universe. And at some point when I was doing some studying and looking at like some medieval history and kind of the history of science, one thing that really struck me was the fact that there is so much that as a scientist I was taking for granted. I take for granted that if I'm studying, right, I'm doing a systematic study of the structure and behavior of the physical world, that it's going to act in a logical or reproducible way, that it's not random. And when I read that, I was taken back, and it was just a very interesting realization. So as I mentioned, this is going to be a little bit more autobiographical, but I would say hopefully towards the end, you will, I hope, be inspired simply by the fact that if we cooperate, right, in this great plan, that we can do amazing things. And so I'm going to start out in a moment. I'm going to ask kind of informally, since we're doing this via video conference, I'm going to ask who you are. But here, to kind of kick this off, I'm going to say that I am a husband. I am a father to 6. Now, 3 of them are born. 3 of those were miscarried. I am a godfather to 8. I'm a native Texan. So here in Maryland, where we currently live, I'm out of my element. I am, if you've ever taken a Myers-Briggs type indicator, I am an INTJ. You'll see today that I am a cradle Catholic, right? For those of you who may not know the term, that just means that I am a Catholic since birth. I am a disciple of Jesus and Mary, and that is in a more formal sense. There is a Catholic lay group called the Disciples of Jesus and Mary that I'll be referencing some of the guiding principles. And then if you've ever heard of Saint Maximilian Kolbe, who we just recently celebrated a feast day of, I think. I'm also a member of his mission, Militia of the Immaculata. And then, right, I would say more relevant to a normal academic talk, I'm also, I would call myself a scientist, more specifically a computational biologist or a bioinformatician. I would say I'm also an educator, and then as we'll see, part of my particular path and my contribution, right, as I've come to understand it, is as a builder, right? Now, today, I'm going to assume, and I would say you're welcome to put in the chat if you care to offer up, although I would say you don't have to, right? I'm going to assume that a number of you are Catholic. I'm going to assume that there are non-Catholics, right? I know that when I was going to UD, there were non-Catholics there. And so if you have a faith tradition, that can be Christian, i.e. Catholic. It could perhaps be Jewish or Muslim, right? It could be that you refer to yourself as more religious or spiritual, or it could be that you don't really know and right, would refer to yourself as agnostic, or you do not believe that there is a God at all. With regards to, let's say, major, I suspect that there are a number of you out there that are biologists or biology majors, perhaps some chemistry majors or physics majors. A new one since I've been at UD is the idea of the computer science major. As Dr. Toby mentioned, I have my concentration, right, in computer science. I suspect that there may be mathematicians out there, and then I also hope that we may have, say, some liberal arts, majors, right, whatever the various history or philosophy or whatever. And then I also suspect that there are some who are, right, undeclared. And then there are also going to be, I suspect, a number of you that are undergraduates, perhaps some graduates, some faculty, as well as perhaps, say, staff and alumni. And so my talk today in the idea of bridging science and faith is that what this is really meant to do is to bring to the front that science and faith, or in other words, science and religion, they are not opposed to each other. I happen to live that on a daily basis where they are not opposed to each other, but I would say where UD, I think, is a special opportunity is in the sense that right, we can discuss, right, our faith and science in the same breath or in the same sentence. And so what I'm going to do, because I have not surveyed you, nor everybody at UD, nor everybody in the world, all I can really do is talk about, right, how I bridge the science and faith. And so, as I mentioned, I'm going to talk about it from the perspectives of faith, family, education, and then work. And what this really reminds me of, as I mentioned, as part of this lay group, there are 5 principles. So one of the first things, or actually the last principle, is that God made us or created us as unique individuals. And this also reminds me of a quote, and I was actually having trouble finding it, that when we read about the saints, if you are Catholic, or if you read about those who have exemplified, right, the faith tradition that you follow, those stories are not meant to be replicated in your life. They are meant to serve as inspiration, right? And so, in other words, when I read about, St. Francis, I am not called to go and live out the exact same life that St. Francis is. Perhaps there are those who are called to live close to that life, but still, right, each of us are unique individuals. And so this is one of my favorite quotes, and something that I would love for every one of you to internalize, regardless of whether or not you find yourself faithful at all. And that is this quote from St. Catherine of Siena, who is a doctor of the church. And it is, "Be who God meant you to be, and you will set the world on fire." So when I think about that, or I would say I would invite you to ponder that, if you were to live your life and do the best, or be the best person you could be, how would your world change? I suspect it would change in amazing ways, right? And so I would say I invite you to live that way. And so with regards to bridging, right, science and faith, in my faith, right, as I mentioned, I'm a cradle Catholic. I had a very good friend after college who challenged me on my beliefs. I would say that she was very much anti-Catholic, but she was put in my path for a reason, I believe, because that made me learn more about my faith, and it was phenomenal. Before meeting my friend, while studying at UD, I, like all of you, I suspect, right, had to take Understanding the Bible. And at the time, I loved the idea of taking the class. However, it was challenging for me to read, right, the passages in the Bible that I was supposed to, and so studying for that class was difficult. I do want to let you know that I prayed. I think this was probably more of, say, the day of each test. I prayed for instant illumination, and I told God that I knew that if He wanted to, He could instantly give me all of the information that I needed for that test. But I'm also here to tell you that it didn't work. So perhaps you can pray the same prayer, the same idea, and get better results, but it didn't work for me. Now, in hindsight, of course, that's a good thing. I had to, learn my faith, and so here we see that there is one of at least a few passages in the Bible that I tend to remember, and this one from 1 Peter 3:15 is that we should always be ready to give an explanation to anyone who asks for a reason for the hope that is in us, but we're also called to do it with gentleness and reverence. And so I like that very much. Now, my faith, this gets at the idea of that opening quote of science. And so when I read a little bit, or I think I may have actually been listening to some of like the great courses on medieval history, and it was very enlightening. And so here, this is a capture from some Wikipedia, and where it's talking about, say, science in the Catholic Church. And so we see that following Rome, right, monasteries and convents remained bastions of scholarship in Western Europe. And the clergymen were leading scholars of the age, studying nature, mathematics, and the motion of the stars. Right now, that was largely for religious purposes, but I think nowadays it is common to hear of the Middle Ages as the Dark Ages. And I think that's a relatively new concept, and I would say it's a misnomer, right? There were lots of inventions, there was lots of discovery going on. I would say not at the same pace as we encounter it today, but it was definitely not dark. And so during the Middle Ages, right, the church founded Europeans' first universities and produces scholars like Robert Grotesque, which I'm not familiar with his work. I do know Albert the Great. That is, he is the patron saint of scientists, and somebody whose little plaque I have here on my desk. And what is also very interesting is that he was the teacher, the mentor to none other than Thomas Aquinas himself. And so we see that there was a number, right, of important individuals in the Middle Ages, and the fact that the church helped to found, right, the universities, and that idea of science, right, if God is benevolent, right, and He made everything and everything is good, then that means I can study it, and I can expect, right, that if I do my experiment over and over, I'm going to get the same result. And so when I see God working in my life, right, that strengthens my faith. I think that being a scientist makes my faith stronger. And this is where we get at, once again, that idea of, you'll see over and over again, hopefully I will do a good job of describing it, but There are a number of times in my life where I have intended to take a particular path and an option has opened up to me, and that's not something that I would have ever thought of. But after right, consideration and prayer, I take it, and then that path ends up being, right, a very beneficial one. So that is what I would say is the provenance, as I hope you will see. And then this is another quote, as we were just talking about from Francis Bacon, that I love. And so a little knowledge of science, right, makes a man an atheist, but an in-depth study of science makes him a believer in God. And so I love, I don't know if you all are the same way, but I love to read, news stories that come out about science, or if there are, photographs of something that is newly discovered, and to look at these particular photographs or these new discoveries and just to see the beauty in them, it makes me, it strengthens my faith yet again. So, in addition to my bridging of science and faith in my faith, it also happens in my family. And I don't know about you all, I felt right from the very beginning, I think that my vocation was to be married and to have children. I ended up not getting married until about 35, which I thought I was ready or wanted it much sooner, but I would say God had other plans. I am the product of a Catholic mother and a non-practicing Methodist father. And I would say one of the things that really changed my world, especially with regards to career, was having children. Right? When it was very easy for me in the time before I was married or when married and without having children, especially before being married, to be working at UT Southwestern and to work at any and all hours, and just there were no other priorities, right? It was predominantly, say, work was the priority, but having children does wonderful things, right? And so from the aspect of say, bridging science and faith, when you have children, and so what we're looking at here isn't just a generic picture, these are actually my 3 children, Madeline, who is now 12 in the middle, Isabella, who is 9, and then Joseph, who is 4. And as a scientist, I've always loved learning about the world. And as we'll see, I not only come from a family of educators, but I do a lot of education or training. I want to share, right, what I know about the world and what I've learned about the world with my children. And so I also want to instill in them a love of learning, right, and a love of discovery. And so this is where I have this belief that everybody is born a scientist. Sadly, some people just kind of talk or work themselves out of it, right? And so if you've ever looked at children making mud pies, they are in essence doing experiments, and it is wonderful to see. Now, what is rather interesting, right, with regards to the idea of like bridging science and faith, because of that love of learning and right this love of faith, we have decided. So my wife is gracious enough to homeschool our children, but I would say that that is a particular life choice, and I would say certainly in the neighborhood that we live in. We are very blessed where we live in Maryland. What you see in the picture here is a picture, I think it's like 2 or 3 years old, of our backyard. And when storms happen, the way that it works out, after a storm, it just ends up being this beautiful, beautiful rainbow, many times where you can see, right, the beginning and the end, right, of the rainbow. Now, I actually haven't tried to chase it down, so it's possible there's gold there. I just have never found it. But the bridging of science and faith here means that we are, applying, or we're that love of learning. We are taking that right in our education. We can go out and hike. I don't know that you can necessarily see it, but there is this rather short or small mountain in the background of the picture, Sugarloaf Mountain. And so there are wonderful ways to deal with the world or interact with the world and do it in a faithful way, right, in our family. Because we homeschool, right, that means we have a single income. But what is rather interesting, especially in light of doing this talk during a pandemic, beforehand, when I was working, I was able to do telework. That means work from home 2 days a week. And so, of course, then once the pandemic hits, that is something that moved to 5 days a week. But because we were homeschooling, and because I was teleworking from home already, I would say that our lives changed, right, a lot less than I would say many others, right, lives changed. Now, speaking of education, right, we'll discuss more of this, and especially say time at UD, and I think that was one of the interests in quizzing you all. As I've mentioned, I have a great love of learning, and I want to know more about the world. And from a scientific perspective, there are these neat little graphics, and I didn't have time to put it in here, but the idea is that when you finish your PhD, you are to have discovered something new that has never been known before. And so by doing that, you are then slightly, ever so slightly increasing, right, our knowledge of the world. And that is the world that I believe God created. And so I love the fact that with regards to, my education, I can learn more about the world that God has created. And in expanding my education and almost finishing my PhD, then I can, right, help to contribute to that knowledge. This is a wonderful quote if you've ever heard it or if you've never heard it. So this is a quote from Isaac Newton to his rival Robert Hooke at the time. And he was saying that if I have seen further, that means in his discoveries or in his work, right, it is by standing on the shoulders of giants. And so this is something that it is pretty common for us to hear about in science. But I would say in part, right, those giants could also be the saints that I'm learning from as well. And so here what I'm going to do is I'm going to just very briefly discuss work, and then we'll get into the depths that we talked about earlier. So my work as a scientist, right, I believe that there is reason, right, in the church, and that right, we have science as a discipline, right, and I think that science needs the church just as much as the church needs science. And so especially when I think about just how much in studying infectious disease, it is a reoccurring theme over time. And if you look, I think in my book references at the end, there is a particularly good book from an author, last name is Barry, and it is The Great Influenza. And it's really interesting to see the parallels from, say, the 1918 influenza pandemic and today, and just how that affects people's lives and how it affects their faith. My particular job nowadays includes a lot of overseeing the training that NIAID does from a bioinformatics perspective. And so I will talk a little bit about work as being an educator, right? And then we'll talk quite a bit about work as a builder. And so initially when I was at UD, my initial interest was to go and get a PhD in the biological sciences, run a lab, and discover that one new little thing. But that was not meant to be. And as it turns out, what I find is more applicable to my skill set and more enjoyable, excuse me, is to develop systems where instead of moving a particular field forward a large amount, perhaps, or if you consider a doctor who is helping an individual patient, right, but doing that entire work to get that patient better, much of what I do is to move an entire set of people forward, albeit a smaller amount, right? So that means in training, many people at a time, or setting up bioinformatics portals where anybody can come and do their research, but it is moving an entire set of people forward instead. And so that's where I mentioned the idea of builder. And so, don't hesitate. Let me know if you have any questions. What we want to do at this point is to go a little deeper. And one of the first things is, I think that is as perhaps rather unique, is I remember very specifically the first time that I ever heard or saw DNA. And I remember this being in a 7th grade science class. And for some reason at that point, I knew that that's what I wanted to study. It was just incredibly intriguing to me. And I mention that because if there are those of you who go out and perhaps become educators, please understand that a simple lesson on DNA in a 7th grade science classroom may have a profound impact on one or more of your students. So, UV, excuse me, sip here. As I mentioned, right, I wanted to become a scientist. I thought I would run my own lab. I knew that I did not want to be a medical doctor. And I hoped that I would help many people, but already I would say before UD, the idea of being a scientist and doing some type of discovery, but adding to the knowledge, right, and of the world, and perhaps never being recognized for it was very attractive to me. I would say now on the flip side, there were times that the prideful self thought, how wonderful would it be to do work worthy of a Nobel Prize. But well, that's, I would say I began to understand that that striving for that isn't necessarily my goal, and if it happens to happen, great, right? And so with those kind of career goals in mind, why did I pick UD? Well, because I wanted to be a scientist, right, run my own lab. I was not interested in becoming a more general biology major. And so I looked for a university that offered biochemistry as a major. I wanted a university that was Catholic. I was relatively strong in my faith at the time. But I also wanted a university that was not in my home city of San Antonio. And so I looked, around and applied to a few universities in Texas. and so was interested in large part in staying in Texas, just not in San Antonio. And so then, of course, UD fit the bill and very well. And I would say, as it turns out, it was not something that was initially on my list to look at. I had a good friend from high school who I think may have gone there for her first semester. And so I was able to come up and visit and really liked, what UD had to offer. So I attended UD from the fall of 1989 through January of 1994. And so for those who are doing some quick calculations, that means that it extended right beyond the normal 4 years. And so the choice that I ended up making, as you'll see a little bit farther down, was I added the computer science concentration in the spring of '92. And I did that knowing that it would delay my graduating from UD. So if you do the calculations yet again, if I am initially meant to graduate in the spring of '93, then starting a program that requires 4 courses in the spring of '92 wouldn't work out. And so I would say overall, that has been one of the best decisions of my life. And so I would say if you find yourself in a similar circumstance, I would say it was well worth it. Excuse me. And so as you see, when I graduated from UD, I had a rather low GPA, a final GPA of 2.5. And that made some of my path forward harder. So the idea of trying to get into graduate school, that made that more difficult. Now I would say things have worked out well after that. And as we'll see in doing master's work and PhD work, those times of low GPAs are gone. But I would say that if that is a situation that you find yourself in, there are a couple of books towards the end. I'm reading a book on atomic habits now, but there is a book on deep work that I think could be very beneficial. And it also could be beneficial to everybody listening. And so I had some different philosophies back in college. I thought, or what I would normally do is take the harder path to a class or a project, but I didn't match that with good study habits, right? And then as I'm learning at the time, I was very surprised to see how little scientists were using computers in school, and this was even right in the early 90s. Now, as part of the Bachelor of Science degree, they had this requirement, right, where you have to do summer research. And this is where a visit to UD of a former alumni was very helpful. So Dr. Fred Kadlubar, who was a UD grad, came back and gave a talk that I went to, and it sounded intriguing. He worked at the National Center for Toxicological Research in Jefferson, Arkansas. It is almost invisible, whether you're looking on Google Maps or not. It is an incredibly small town. I would say, is it about an hour southeast of Little Rock, Arkansas. And what is very, very intriguing, and I think rather influential, and more so than I would have ever thought, is the fact that it's a former biological or chemical weapons research facility. And so I suspect that most of you are familiar right? We understand what a biological weapon is, right? That is either a bacteria or a virus that can be weaponized. And in the 1950s, this was something that was available for or research that was done. Let me see here. I just had to plug in, right? So this was research that was done in America, right, as well as in Russia. And in large part, right, the idea was that we thought Russia, from my very limited understanding, right, we thought that Russia was developing biological weapons. And so we felt, right, that means the US felt that we had to do the same thing. And so by the time that I got there, right, in the summer of 93, it had been a research facility, right, a more generic research facility for the FDA for 20 or 30 years. There, I was able to do some real research. I was able to get my first experience with some scientific computing. And to blow your mind, this was before the World Wide Web, right, was invented. So I would say about 6 months to a year before the World Wide Web was invented. And so if I were to try and play on the computer, it would be without the World Wide Web. And then what is also rather hilarious here is that I lived in Little Rock at the time at the university, because that's where I could get a cheap apartment for the summer. And I had a 1-hour commute. Now, it was a beautiful commute, but as you see here, that seems to be a reoccurring theme, because now here in Maryland, when I drive in, it tends to be an hour to an hour and a half. So when I was at UD, right, when we talked, there were a number of interests in discussing, right, say science and the liberal arts. My career, right, bioinformatics or computational biology did not technically exist when I started college. And so having gone and gotten a liberal arts education, a science-focused one, is something that will prepare you for the rest of your life, regardless of whether or not you work in your major. And so that reminds me that, you know, many of my friends that went through the computer science concentration, they now work in computer science or in IT, despite the fact, or you know, if it's basically totally unrelated to many of their majors. So I find that rather interesting, but it also talks about the strength, right, of, say, that concentration, right, at UD. And so I hope, right, that you will be able to take some or to give you some take-home messages. And so in light of my struggles, right, as an undergraduate, I would invite you to focus, right? That means to study smart, right? The time that you have as an undergraduate or graduate will never come again, right? I would say, don't be afraid to ask for help. When we talk about, right, education or science and the liberal arts, if you've ever looked at job advertisements, one of the first things that you will see, or one of the things that you will always see, is this cliche of they would like good communicators. I will be the first to tell you that there are a lot of people who are not good communicators. There are a lot of people who are good communicators, and yet I have been at the table many times where people are speaking the same language, but they are on totally different pages or levels, and I end up translating from English to English, right? And so the idea of good communications, while being cliche, cannot be underestimated. And that is something that we get, right, at UD, right, as liberal arts, as being liberal arts educated. Ultimately, within science, one of the best things that you want to do is to be able to tell good stories. And so when you go to write up a scientific manuscript, we are supposed to make that informational, right? We're supposed to communicate something. But after you've read a few, you understand very quickly that they're not that exciting to read. And so the more that you can make your stories good, whether it be giving a presentation, right, or writing a manuscript, it's going to go a long way to helping you in your career. I had the option to take ethics from Dr. Janet Smith at UD, and I would say if you, as a scientist, have the option, especially to take bioethics if it's still offered, I would highly recommend it. I think we're beginning, we understand that today that ethics and bioethics is more needed than ever. When I thought about how to right, address the idea of liberal arts and the sciences, there are ways that, say, philosophy or studying philosophy have helped me, which I would have never imagined. It helps you to think, it helps you to think more clearly, and I would say, I think helps make me a better programmer. But there are also ontologies, and if you've never heard of an ontology, that is something that has two different aspects to it. It has a controlled vocabulary. That means that everybody agrees on what the words mean, right? And then it also has a formalized way of defining the relationships between those terms. And so ontologies are used in bioinformatics and computational biology to help us make inferences where we can utilize the computer to its best abilities while saving, right, the kind of necessary work for ourselves. But that is another way in studying philosophy that has helped me when I had to jump into, right, working with some ontologies. And then, as I mentioned, right, we see nowadays where you have lots of life issues, I would say lots of political issues, right, that have to do where there is a basis in science. And so the need for science, the need for explaining that science, right, is even more crucial nowadays. And then at the end, I will discuss or just mention, show you the covers, right, of the two books that I think are relevant. Now, I was blessed, right, to have gotten my BS in biochemistry and computer science concentration from UD. Some years later, I went and started work on my master's, and I got my master's at UTA in computer science, and then have done all of the work towards the PhD with the exception of finishing up some research and a dissertation. And so we'll cover a little bit of that with regards to the research, okay? Now, with regards to research, I learned a lesson very, very early that just impressed me to no end. And it was the lesson, as I mentioned earlier, of provenance. And so there was a question about what happened after UD. Well, I loved UD. I loved being in Dallas. And so I wanted to stay in Dallas. And, you know, as is required, I started looking for, I think it was like 9 months ahead of time, something on that time scale, you know, for different jobs in Dallas. Because I knew that I didn't want to jump right away or try to jump right away into graduate school. And so I looked and looked and looked, and nothing was coming up in Dallas at the time. And so I finally started looking for jobs in San Antonio, and I figured that I would go home for some period of time. And I ended up getting a job at the Cancer Therapy and Research Center in San Antonio, doing some basic cancer research on telomeres and telomerase. And after, you know, doing that and applying to grad school and not getting in, and working there for a year and a half or a couple of years, I wrote to, so I took the initiative, which is another thing that I'm going to recommend highly to you. And I knew that there was a researcher in Dallas doing the same research I was doing in San Antonio. And so I emailed him and I mentioned that I would be interested in knowing if he ever has any positions to please let me know. And that didn't go anywhere as far as I knew. I would say at some point after that, a good friend of mine from UD called me up, it was on a Thursday night, and said that she was quitting her job as a teacher, and she knew that her principal was moving to a middle school in Dallas, to St. Monica's, and that her ex-principal now was looking for a science teacher. And she asked, would I be interested? And so I was like, well, I don't ever close any door before it's actually opened, as I like to say. So I went up and interviewed. I walked out with a contract that I just needed to sign. And that ended up bringing me back to Dallas. And I will have you know that I had horrible long hair everywhere in that interview and still got it. And so I ultimately took that teaching position and returned to Dallas. And about November of that year, so I returned in late July or August, and I believe it was November of that year, the researcher that I had cold emailed replied and said that he had a position open at UT Southwestern in Dallas, and that I was welcome to apply. Well, I mentioned that I had signed a contract for a year to teach, and that I planned to honor that contract. And I told him that I was, teaching. And as it turns out, despite the gentleman, the doctor, being Jewish, he enrolled his children at St. Monica's, right, at the same school where I was teaching. And so I ended up finishing my year of teaching, and though loving it, decided to go back into science. And after working in that lab for a couple of years, ended up not getting into graduate school again. But just the idea that my boss, right, was sending his children to this school that had, in large part, nothing to do with his faith, was just another example of God working in my life. And right, that bridge once again between science and faith. It was like, okay, well, I feel as though I'm doing what I'm supposed to be doing. That taught me a very early lesson on trust. And so after not getting into the graduate school for a second time, this was the late 90s. I could use a computer and program and do some stuff fairly well. And so I was determined to get out of science. I was fed up. I was going to get out of science, go into computers, and make a lot of money. And so normally, when I was looking for jobs, I would stay at UT Southwestern's website and look for a job. I decided not to do that. So I purposefully did not look for a job at UT Southwestern's on their website, but I found what sounded like the ideal job. It involved some computers, and it involved some research, and it just happened to be back at UT Southwestern. And so this is another one of those things where you may have heard the joke where if you want to make God laugh, you tell him your plans. And so, as it turns out, I returned or I switched jobs at UT Southwestern, and I joined the Center for Biomedical Inventions. And this is where the idea of doing infectious disease research continued right? And then really began to take off. And so a large part of what I was doing there was helping with a patented process called genetic vaccine discovery. We had a lot of DARPA grants, right? This is the Defense Advanced Research Projects Agency. And so they were funding vaccine development for agents, especially bioterror agents, that were not commercially viable, right? That means that a company, there was no way they could make money on an anthrax vaccine because there was no threat of anthrax. But so the government or DARPA was funding this. And as part of this, there is a rather interesting circumstance where while doing this work, we were joined by some Russian scientists, and the State Department had arranged for us to, now at the time I was doing computer work, right? And so was not working at the bench, but we had a collaboration set up, as I understand it, by the State Department, where some Russian scientists from Vector Labs came over, and so we started doing some Ebola, right, vaccine work, and so I would say it was interesting enough to where, as you can see, the Dallas Observer decided to write a story on it. You can go and find the story and read up on it. It's from Russia with Bugs, and it discusses, you know, the development of the Ebola vaccine at the time. As you can suspect, right, as we'll get to in a little while, nothing came of that work as far as I know, right? Because we still have outbreaks of Ebola, but it was rather interesting, and you know, just intriguing, right, to be doing that type of work. And so that then led to, right, doing some work for a biotech company, or that process, right. We left and started the biotech company, okay. And this is, right, another example of where the idea of bridging, right, science and faith occurs yet again. So I was the sole bioinformatician at this company, developed an in-house laboratory information management system. And as we were going through a second round of funding, we ended up getting bought out and by a company called Macrogenics. And eventually the Dallas location was closed. Now, before the Dallas location was closed, I would say at least 6 months, if not perhaps 9 months before that happened, my manager, you know, came over to me and he's like, the writing is on the wall. They will probably be closing this location down. And at the time, I simply said, okay. And I kept working. And I kept working and kept working. And now, at the time, I was not married. Perhaps if I was married, I would have had some different thoughts. But I felt this trust, and that when it was time to go, I would know that. And so my manager came and talked to me yet again a few months later, and that the writing's on the wall, and it's time, you know, for you to start looking. I'm like, okay, like, thanks. And I blew it off a second time. And then the third time he came around and he said, and this was, you know, another perhaps 6 months after he first mentioned it. And he said, you know, at this point, right, so now things are basically finalized, right? They are going to be closing up the Dallas facility, and you will be laid off. And it was like, okay. So I started, you know, looking for jobs again. And another crazy thing happened. So the day I had been sending out resumes to any interesting job that I could, you know, find, I had sent a number of them out to institutions. At this point, I wanted to stay in the DFW area, and so I was applying to jobs there. And that would have meant, right, getting out of infectious disease work, which isn't what I wanted to do, but if that's what I had to do, okay. At the time, I had just bought a house and a car, but I felt peace. And as it turns out, the last day at the small biotech company, I got a call for an interview for the job that I would then have a month later. And so it is another example where this providence or this faith, right, helped me in my work. Okay. When I rejoined, remember I had left to go to a small biotech company in Dallas. I joined UT Southwestern yet again, and this time to work on a contract as opposed to just a regular grant. I joined a project that was funded by a contract, and it was for one of about 8 different bioinformatics resource centers. And at the time, we were called the BioHealth Base, and we were involved in influenza research, tuberculosis research, tularensis, and ricin toxin. This was about a month after it had been funded, and so it was a very exciting time. And this is where the idea of building systems, I would say, really solidified for me. So what you see here is a screenshot that doesn't look all that different from today. Actually, so this is one, I guess, is perhaps I've updated it a few months ago or something. But this Bioinformatics Resource Center is a portal that you can go on. Anybody can go on. You can create an account. You can do bioinformatics analysis at no charge, right, on this resource. It deals with influenza. There is a sister website or a corresponding website called the Virus Pathogen Resource Center, or VIPER, and that is at viprbrc.org. And I think I have those somewhere in here. If not, I will put them in there. But this project was infectious disease based. We were working with lots of very interesting viruses and bacteria and toxins, and over the course of time, right, it was initially funded on a 4-year cycle, and then refunded for another 4 years, and has subsequently been refunded. But this is where I was doing research and work, and then encountered, right, the first pandemic, right, of my career. And so for those of you who may remember, there was a pandemic in 2009, right? It was the influenza H1N1 pandemic. And this pandemic, it ended up emerging out of Mexico. There were some people who were just happened to be part of an early study in California, where the sequences, the very early sequences came from. And at the time, right, you didn't know if you have ever looked into the history of influenza. And as you may have heard recently, right, there was a worldwide pandemic in 1918 that killed between 50 and 100 million people. And in large part, much of those fatalities were within until they have, that's when they died. Thank you, Dr. Toby. And so I'm gonna skip ahead here. I'm sorry about that. But influenza, right? It's a negative stranded RNA virus, okay, that has, right, the H and the N, they talk about, or those are the proteins on the surface, right? I'm gonna, as part of this IRD we had put together, we brought together public information, okay, publicly available data, and then made it available for researchers to use. And you'll see here that we included, right, surveillance information and three-dimensional structures. And part of what we were doing was we were looking at, right, how to potentially design vaccines. And so this is, I would say, is potentially relevant, right, today, where an ideal immunogen, right, is one that evolves through competing forces of immune pressure, oops, let me go backwards a minute, works within the protein functional constraints. And so the idea is that you want to, the virus, right, it wants to evolve or change, but it can't do it if it can't continue to replicate, right? And so one of the things that we did was to look at what we called conserved epitope regions. And here we took data for polymorphisms, and we mapped that polymorphism data out. We took data that was available for epitopes, or those are the regions that the immune system recognizes. And we did this for all of the different sequences in the influenza. And then one example of that you can see here, where we went through and we found, right, these particular regions that we see colored up above here that are very conserved, but immunogenically active, right? And so that's where you see the green and the red lines are increased, but the blue here is very low. And so this was just an example of how, if we took those proposed regions and we looked at the time, right, we didn't have the ability to go and put that in an animal and test it, right? That was beyond our scope, but we could go through and we could look in literature and see and find, in fact, that there were broadly neutralizing antibodies, right, that were available, that had been detected, that fit the regions that we were able to predict. And so I know this is a whirlwind tour here, and I'm sorry about that. But the idea was that you were able to use this data to, right, predict potential vaccine candidates, right, using only data and your computer. Okay. In addition to that, some of the work that I've done for doctoral work is to look at the sequences, right, using the pandemic influenza sequence. And this is a map of its changes, or how it is similar to other sequences across time. And so here at the bottom here at 00 is the 2009. And then these are older sequences that are increasingly dissimilar to that pandemic sequence. And if I skip ahead here, then what we will see is that some of them are very similar, some are very dissimilar, right? We saw that those sequences were, that the changes were carried over time in these multiple sequence alignments. And ultimately what we were able to determine is that we predicted that these sequences along the diagonal here are what we would call evolutionary trajectory sequences, while others are not. And then the interesting thing is that this last sequence here is in fact, and I can do that, is in fact the 1918 sequence. So I'm going to skip over some of the data here, but we were able to go through and quantify that. We were able to use a similar technique to do some norovirus analysis a couple of years ago. Noroviruses are viruses that infect or that basically cause stomach aches or that kind of thing. And so there are, a number of ways that you can use the computer to do right, different types of research here. Let's see here. And so what I want to do is I want to move ahead, and if we've got a few more minutes, then let me go and see here. So we've talked about science, right, and say work as a scientist, and the idea of you know, being guided. And so every time that my boss needed me to move to a new area, I went and thought and prayed, and then took that new area, that direction that was given to me or requested of me, and it ended up making, right, all the difference in the world. And so then nowadays, much of what I'm doing is talking or working with education, and so trying to take, you know, what is known by, say, myself and colleagues, right, and then educate, say, the next generation of NIAID scientists or even NIH scientists in general. And so, right, this is where I feel as though one of the other DJM principles comes in, where to whom more has been given, more is expected. And so, you know, this gives me the opportunity to, I have learned stuff and now I can share it. And so we talked a little bit about, say, the builder perspective. And when you look at the Bioinformatics Resource Center, right, such as the Influenza Research Database, that is something that, right, anybody in the world can use, right? And you, in essence, are building something that moves, right, the entire, say, field, or anybody in the, right, who's interested, even those who are, say, undergraduates and want to look at it, it enables them to learn and grow, right, in science and learn more about the world in which we work. One of the more recent pieces of work that I've done is on reproducible science, reproducible research. And as you'll see, much of what we have today is available at no cost, right, for everybody to use. There is some information that I will send out with the slides and making them available. And so that if you're interested, you can go and, say, look up, right, doing reproducible research with Jupyter Notebooks. I'm going to pass over acknowledgements, but acknowledge that the vast majority of the stuff that was discussed was definitely not my work alone. Okay. And let's see, before I get to some questions, I'm going to suggest that you pray, keep a journal, that you develop a LinkedIn profile, that you create a GitHub profile if you haven't already, and then register for what's called an ORC ID. And this is a very general ID that you can take, and that will link all of your other scientific information.
Thank you so much, Mr. Squires. And I recognize that quite a number of you have had to go offline due to courses that were starting at 1:25. So I just want to say a big vote of thanks to Mr. Squires for the time that he has spent so graciously and really giving us lots of meat to chew on. Wow, lots and lots of important takeaways from this in terms of communication and lots of interesting readings as well that we should all look to. Before we probably take one or two questions, I do want to introduce the student representative that has been working sort of on the front lines for the Computer Science Club and the UD Bioinformatics Club. So Joseph Galasso has been spearheading those efforts. So I just wanted him to give his brief vote of thanks. And then again, we'll just take one or two questions. Thank you so very much, Mr. Squires. So Joseph, are you on? Can you give a brief vote of thank you?
Yeah, sure. Can you hear me?
Yes, we can.
Great. So yeah, my name is Joseph Galasso, and I'm the president of the Computer Science Club at this school. And First, I just want to thank Mr. Squires for taking the time for this wonderful talk. But also, I just wanted to say that the Computer Science Club we're going to be starting up meetings again soon, and we're going to hopefully be planning a lot of virtual events for this semester that will really help students learn basic principles of computer science regardless of your major. And so if any of you are interested in that, please let us know. And one of our subgroups, the sort of ACM has multiple sub clubs, is a bioinformatics club. And the focus of this is especially for a lot of science majors like chemistry majors, physics majors, or biology majors, and even computer science majors to just sort of come together and work on bioinformatics problems to try and develop skills, important skills in data analysis that will really help boost your applications to graduate school or medical school, and also just give you really important skills for later in life. And so if any of you are interested, please contact Dr. Toby or me, and I can put my email in the chat after this.
Yeah, that'd be great.
But yes, but thank you again, Mr. Squires.
Thank you so much, Joseph, for your hard work and efforts. And I should say, Joseph is one of those students that is doing both the computer science and biology. And so he's similar to Mr. Squires, he's going above and beyond the credit hours that he would typically be doing just to accommodate having both of those educational experiences. I do see an alumni, at least one or two on the call. Thank you for your time. Thank you to the faculty members that joined. Perhaps what I would do is I'll just pose one or two questions to Mr. Squires, and we do have a Google Doc that's circulated, and we'll probably use that, and he may point you back to some of his responses, and so you can walk back through the document and see his potential responses to those questions. But one thing I would ask is, what is the importance of students engaging in service in terms of for future jobs, future positions, in terms of the perception that this gives to future employers? And are there specific types and ways in which students can apply service? So if you could comment on that, that'd be great.
Sure, any particular types of service that you're talking about?
So voluntary work, nonprofit work while they're still at UD. Are there any of those types of experiences that would be better than others, or is any kind of service opportunity something that would be seen and perceived favorably by future employers or even graduate programs?
I would say certainly. I mean, the idea is if you are doing some type of service, especially if you are giving your time for free, what you are saying is that you believe enough in the mission of whatever that institution is, that you're willing to give your time for free to do that work, right? And that goes a long way to communicating to future employers that this person, they have something that they believe in, and that you can, and they're willing to put their feet, their hands and feet to work to justify that or to assist.
That's great. And let's take a question from one of the audience members. If someone could go ahead and pose a question to Mr. Squires, you can unmute yourself or come off the, open up your webcam as well. So go ahead if an audience member has a question, go for it. If not, then I'll go to the next question that was on the list from the students' questions. How do you see science changing post-pandemic in terms of how we do science? And what opportunities should researchers at smaller institutional research programs like at UD take advantage of?
That's a great question. So one of the profound changes that we are seeing right now is the fact that this is the first time in history where preprints are a major deal with regards to the pandemic, right? So in a pandemic, things change on a daily basis, right? In the very beginning, we knew next to nothing. And so our information is constantly changing. That goes in some sense directly against the idea of publishing in science, right? The traditional publishing in science means I do my research, I write up my manuscript, I send it in, it takes months to be reviewed. If everything is okay, then it gets published. Those months can be perhaps deadly, right? And so we're seeing that there are ways where I can publish a preprint and I can have that up, right, in a day. If I need to make changes, I can make those changes in a day. And so that is a not necessarily a blessing and a curse per se, but we have to take that with a grain of salt, right? In the sense that we must understand that those have not been peer reviewed, but is there something that we can glean from them? And so I think nowadays where you have the idea of preprints, you can do some research in an afternoon and you can put a preprint up. And then it has a unique identifier that you can put on your CV and send that out. You also have things such as Amazon Web Services. So if you want to do huge compute analysis, you don't have to wait to write a grant and get money or go and beg, to do some work on a borrowed time. If you have a credit card, and I would say probably $10, maybe even $100, you have access to more computing power than anybody else has had in history. And so, those ideas make it to where competing as a small university researcher, it helps to really level the playing field.
Yes, those are excellent points. Again, I just want to send a heartfelt thank you. This has been a very refreshing presentation, and I'm sure all of the participants would agree. And in future, we will certainly love to have you back again, and just to engage with the students some more. And again, for those that have questions, you can post them in the chat and I'll include them in the Google Docs. So when I circulate it to students, you'll see Mr. Squires' responses on the document. So thank you all for coming. Thank you, Mr. Squires. Thank you for your time. Thank you to the alumni and the faculty members that came for your time.
Thank you, Dr. Toby. Good to see you.
Thank you. Enjoy the rest of your day as well.
You too.
Thank you. Bye-bye.